hear me? Yeah. Okay. So, thank you all for joining this workshop on native iOS and Android module development for Titanium. Just a short presentation of myself. I'm Olivier Morandi. I'm a software engineer from Italy. I have a blog which is Titanium Ninja. I'm doing mainly mobile development as a freelancer on Titanium. Sometimes I also do some other engineering stuff. And maybe these are my contacts. And I have a GitHub repository where I've published just a bunch of native modules in the last couple of years. And before starting, I'd like to ask you if you have some experience on native coding, on Titanium module coding, and so on. So, who has some experience on native coding? Yeah, and on Titanium modules? Okay, will be good. Because this will be an introductory workshop probably, so I'll show you how to build a module from scratch for iOS and Android. And I'll show you a bit the patterns that are useful for building a module. And I'll try to not go too much into detail on the specific native side of coding. So I hope you'll be able to follow, even if you don't have much experience with native coding. So, actually, module development right now is a bit off track. It's module development is so 2010 because now all the rage is for Alloy probably. But actually, why should we bother to understand how native module development works? Mainly because we sometimes want to leverage the native features coming from the underlying operating system, or sometimes we want to integrate some already existing third-party library. And sometimes we want to achieve a better performance, mainly for optimizing the user experience. We have a bunch of learning resources available, mainly the official accelerator guides on module development, which are getting better than when I started 2 years ago. But the main resource we have is the source code. And for really understanding what we can do, we really have to dig into the code of the Titanium SDK. And fortunately, we also have right now a good amount of example modules distributed by Accelerator. They are increasing in number. They are available on GitHub. There are also a bunch of developers who are distributing their modules as open source on GitHub, and probably you should follow them. So, before starting, let's have a look at the architecture of Titanium on the Titanium SDK. And basically, as you all know, we have a set of tools which are the Titanium Studio IDE, or maybe some other text editor for writing out our code. We have a set of tools, which are the command line interface based on Node.js, and still some Python scripts, which basically take our JavaScript code and use it for building two kind of projects, native projects, one for iOS and one for Android, which will be compiled and built for the respective native operating system. This at build time. At runtime, what do we have? So our application, how does it work at runtime? We have on top our JavaScript code, which at runtime is parsed and managed mainly by a JavaScript engine, which on iOS is the JavaScript core engine, which is composed by a parser. An intermediate bytecode is generated and interpreted. We have this in the middle, the prod bridge, which is basically the part of code of Titanium that allows our JavaScript code to call functions in native code. And mainly, all the implementation of the API is native modules. All this part is obviously relying on the functionality provided by the underlying operating system and libraries. Yeah, sorry. We don't have just-in-time compilation on JavaScript on iOS. The same structure is present for Android, but Android uses the V8 engine for interpreting JavaScript. So V8 actually doesn't interpret the code, but it compiles it at runtime through a JavaScript just-in-time compiler and optimizer. This just to have an idea on how things work on the two architectures. A bit of terminology. We have our code, maybe it's a bit smaller. So, when we write Titanium UI, create window, the Titanium UI is our module object. All the objects of the Titanium API are actually injected in the JavaScript engine at application startup. The create window in this case, or create something, is called the factory method, which is used together with a set of properties for creating what is called a proxy object. I'll give you more details later. All the objects that take part into the UI are actually a special kind of proxies, and they are called the view proxies. These objects can have properties and methods. So, the architecture, the overall architecture is this one. We have a kind of class which is the proxy, and is basically the base object. And this kind of object is used for keeping state of a native object as properties. We have actions as methods, and we have events that we can use through the add-event listener and fire event methods. On the other side, we have the module object, which is actually a proxy. It extends the proxy class with methods and properties that allow, on one side, the management of other proxies, the creation, and also the integration with the application lifecycle. So we have specific events that can be used for managing the application startup, the shutdown on the OS, and we have a special method on Android, which is the create. New proxies are other kind of proxies, as I told, that extend the proxy object with properties and methods for the integration with the layout system and the UI. So, for example, we have the add method, all the methods you normally use when you create your interface. Add, remove, the height with properties, and so on. The view proxy is in charge of managing and creating the actual view objects that are the native objects representing these views. And it does this by basically creating objects at runtime that are made in some specific way that we will see later. So basically, let's create a module. We have to first create a project for building our module. We have to develop our code. Then we build it, deploy it, and install it for use. And then we can debug it. And then repeat, obviously, because there's always something that doesn't work. So, titanium modules. On iOS, basically we need only the basic tools we already need for normal application development. So the Titanium SDK and its code tools. On Android, we need Titanium SDK, the Android SDK, but also additional tools which are the Android NDK, which is the native development kit, a tool which is called Ant, and a tool, a command line tool, which is Jupyter. Basically, we need these kind of tools installed in our system and available in our path. Possibly, we also use Eclipse for editing and building of the modules. So, the old approach we used for creating our modules was based on using a command line interface by basically creating an alias on the titanium.py script for ease of use, and then use this kind of command for creating our module, either on iOS or on Android. And basically, we have to define the type of project we are creating. As you see, the type equal module. We have to define an ID, just like when we create an application, possibly with the reverse DNS notation. We give a name to the project, which will be used either for the native project and for the directory containing the project in this. We have to define the platform we want to develop on and target directory. But fortunately, lately, this kind of commands are no more needed because the Titanium Studio allows us to create this kind of projects thanks to its UI. We only have to make Titanium Studio to know where our native tools are available. So in the preferences we have to define basically this kind of stuff. So the Android SDK location, because the other information are already generally known. So let's try to to build a module, we open our Titanium Studios. Okay. We have new. Instead of create a new Titanium project, we create a new Titanium module project. We give a name, for example, type sample. We choose a location. And now I'm creating the iOS one, so I differentiate. And we have a module ID, so in this case I write type on. And the workspace. Okay, let's call it so. No, this icon. Okay, this one. Let's call it so. Thanks, Antonio. Okay. In next, we define a version, 0.1, for example, give to me, and so on, description of license, and finish. And Titanium Studio creates a project template, which is available here, and that we'll see shortly. We can do the same for Android. Sorry if I missed. It's the same. So we choose Android. And there's some module class. Oh, okay. We won't go into this route. Okay. So basically, we have to create our modules through Titanium Studio. And what we will have is a project template already containing some predefined examples. We have the main directories we have in our projects are probably the classes directory, which contains the basic class and object representing our module, and a bunch of configuration files which will be detailed later. And maybe I can show you here. So basically, on one side we have the iOS one that in this slide is shown opened in Xcode. And then we have the Android counterpart, which here has been opened in Eclipse. For example, I have another module here, which is this SMS module for Android. The module code is contained under the sources directory. And we have a bunch of other files that are mainly used for configuration. So once we have these two projects that already contain a very basic module with some example methods and properties, and maybe on Android also a proxy object is created. We can take these projects, build them, and install them. So we can do this with a command line interface, which is a command in the resident in the module directory in the project, which for iOS is the build.py script, and then we can install it because the package which will be generated will be a zipped file. And we install this, we can install a module either globally, so installing it in the Titanium SDK directory, or locally to an application. So if we unzip the module in the root directory of a normal Titanium application, that module will be available only for that application. When we build on Android, we don't use the build.py script, which is not available. We use the AND tool that basically goes building all the stuff. And then the target package will be available under the distribution list there. We can also do this on Titanium Studio by using the publish option of our module project. As basically here, Titanium Studio asks us where to install the module. We can install it either globally or in an application project, or specific directory for publishing, for example, the module on the marketplace. Once we have the module installed, we can use it in our application. Basically, going to set in our tired.xml file a reference to our module, as you can see here. And then we can use that functionality in our application by requiring the specific module, calling it with the module ID we choose in the previous steps. Actually, if we this is an example project using the module we did before. If we edit the Titanium application, so here it is not visible, but we can reference the module in this place. But it's the same as basically editing the tired.xml file. So these are the basic steps we have to make to create a module project and maybe build it for the first time and install it for the first time, just to have a look at how the project creation process looks like. When we've done this, we can really start to develop our module, and we have to define what our module will be doing, what kind of entities it will be creating, for example, proxies or view proxies. And here we'll see the the main patterns that are involved in this process. So we'll see the methods, how to create methods for modules and proxies, passing arguments to the methods and so on, returning values, how to generate exceptions, for example, for notifying that we passed a wrong argument to a method, using properties. Then we'll see proxies, view proxies, events, and callbacks. So I'll try to not go too much in detail in the native side of things, but I will still be showing some native code anyway. Please just try to follow not too much the syntax, but the concepts, the underlying concepts and patterns. So here on iOS, how do we define a method for a module or a proxy? Basically, we define something like this. We define its method as a common Objective-C method for a class with this kind of prototype. So if we are defining a module or proxy method, we have to define its method name. We have to define that it takes arguments, and maybe that it is returning an object as a return value. If it doesn't need to return a value, we put a void type as a return value. Similarly, on Android, we have some more boilerplate because we have to tell the compiler that we are defining a proxy method or a module method through the crawl method annotation. And similarly, we define the method name and its return value. The return value type, sorry. In this case, for example, we don't return a value, but we take an input argument, and more or less it's the same. So basically, let's do an example to see how we can map our JavaScript code we have in mind on actual native code. So let's say, for example, that we want to create a module with a very basic method that allows us to convert an XML string into a JSON object, which is very handy because actually processing XML is not so easy and it's a bit cumbersome. So, and moreover, maybe we want to do this kind of operation in a fast way. So it's likely we want to offload this kind of functionality into a native module. So basically what we want to do, we want a module with a simple convert method which takes a string object and transform it, this XML string object, and transform it to a JSON object. Actually, this is a real module I've implemented. I've put a link there, but it's still not published. I will publish it in the next few days, probably. But the link will be true. So we've seen our expected API. How do we implement it? Maybe don't look immediately at the upper part, but just look at this kind of method, which is the convert method, which takes an input argument and returns an argument. Inside, we have a special invocation to, let's say, it's a function, actually it's a C macro, that we use to validate the arguments, and basically it ensures that the argument we passed to the method is a string at runtime, and it returns the result of the conversion. Basically calling this function that do the conversion stuff. The argument we're passed, it's an array object. In Objective-C, when you see the ID declaration, it's basically an unknown object, an unknown kind of object, but it's a generic object. So what the JavaScript engine will pass to our method is actually an array of objects. And the Titanium framework gives us a set of utility methods that allow us to basically validate the arguments passed to a method. And we have a lot. Maybe validating that we are being passed, for example, a string, a dictionary, and so on, or the number of arguments will be passed, and so on. The types. As you know, the JavaScript supports a bunch of types, basically numbers, strings, null, undefined, and so on, plus a set of native objects, types like the array, the date, and so on. All these kind of types are mapped with a one-by-one mapping on native types of the Objective-C part. So a JavaScript string is mapped on an NS string. A generic JavaScript object, which is generally an hash map with a key value association, is mapped on an NS dictionary, and so on. The array on an NS array, and so on. The Titanium framework gives us a set of conversion utilities from passing to one kind of argument to another, casting this kind of arguments to the specific type. And what can we do when we have to return an object to JavaScript from our method? Basically, we have several choices, but if we are returning a string, we simply have to return an NS string. When we are returning an array, we will be returning an NS array, and so on. If we want to pass a complex object to JavaScript, generally we want to pass it as an NS dictionary. So basically, mapping our key value association to property to object associations in JSLang, or in other cases we pass a proxy object. We have to pay attention on the Objective-C part to correctly manage the memory, because the Titanium framework internally still doesn't use the automatic reference counting stuff, which lately has been added to the iOS and macOS development. So we still have to manage the memory with retain, release, and so on. And when we return an object back to JS, we have to return an auto-released object. On Android, it's basically all the same. The syntax is not the same, but the concepts more or less are the same. We have our method convert, which takes a string argument. The good thing of the Android and Java part of the Titanium SDK is that we can really define the kind of arguments we are taking. On the iOS part, we are defining that in a generic way. Here we can actually tell what kind of argument we are expecting. So we say we want a string and we will return a dictionary object. The crawl dictionary that is reported here is basically a hash map, which associates a string key to an object value. And what you will have in JavaScript land, it's actually a JavaScript object. The one you write with the brackets and string colon object. And here it's the same. For the types, mappings are more or less the same. So we have numbers mapped on the native integer or double or float values. Array is mapped on an object array, and JavaScript objects in JavaScript are mapped on a hash map, which is basically a crawl dictionary. And also here we have a bunch of conversion utilities. Same thing for the return values. Exactly the same concepts. As you know, JavaScript methods are polymorphic by nature. So a single method can be used with several types of objects. And how do we manage this kind of behavior in our native objects and methods? Basically, by going to interpret what the framework is passing us in the arguments array. And we have to, for example, if in this convert method we want to take in input a string or a blob object that sometimes is returned by the file reading functionalities of Titanium, basically we go to see what is present in our arguments array. We ensure that we only have one argument with the ensure count macro. And then we use a feature that is present in the Objective-C language, which is reflection, going to see which kind of class corresponds to the object we are evaluating. So we use this kind of class, string, do something as a string. If it's a blob, use the argument as a blob. So we can differentiate the execution path based on the kind of type of object we're passed in these arguments. And the same we can do on the Java side, because we can use reflection also there, and basically looking at the kind of class of an object. So we are passed an object argument. We see if it's a string or if it's a blob, and we do different stuff. We can throw exceptions for notifying both the SDK and the user that, not the user, the developer, that something is wrong. And the same we can do on iOS in Objective-C with the throw exception function. This is actually a method of the proxy object. We can also support variadic arguments, that is, basically have an undefined number of arguments, by basically iterating over the arguments array and do something based on the index of the element we are iterating on. And the same in Java. So, as you see, the concepts are more or less the same. The implementation is a bit different, but just because they are two different languages. Our module or proxy objects can have properties, as you know, because you use them all the time when you create programs for Titanium. So you have the notation module or proxy dot property name as a set operation or a get operation when we use the value of that property. We have on iOS two kinds of routes we can follow. One is to basically define the properties when we declare the class of our proxy or module. So we use this notation, defining the name of the property and its type. Obviously, we probably have to retain it. And with this kind of notation, basically, the Objective-C compiler creates a couple of methods which basically set and get the property. And basically, this is the same that we can do hand coding the two methods that go to set and get the property. It depends. Actually, it depends what kind of stuff you need to do with the property. If you need to do more complex stuff with the property, for example here, you go to set a value but also do something else. For example, notifying a view that something has changed and so on. You use this. Yeah. Basically, the name of the proxy, which is SMS, the class you have to name it SMS proxy. And it needs to extend the base class crawl proxy. And you also have to inform the framework that you are defining a proxy with this kind of annotation. The creatable in module part of the annotation tells the framework that the module, the parent module, can create this proxy through the create SMS method. Otherwise, you can't call that method, and you have to return this proxy through other means. Okay. How do we inform our client code that something has changed in the state of our proxy or our module, or something happened? Basically, we use events, as you already know, and the client application can add a listener on our module or our proxy. And on the implementation side, basically, when something happens that we decided that needs to trigger an event, we can check if the module of the proxy has some listener on that kind of event, the success event in this case. And then we can fire the event through native code. This is a method of the proxy class. we fire an event named success with an object. We always have to pass a dictionary object, which will be augmented with some other properties by Titanium. So basically we create this kind of result object by adding properties to our dictionary. And the same on the Android side. Only the syntax and the class names are different, but the concepts are the same. We have as listeners, which is a method of the proxy. As listener success, if so, we create a dictionary, we add a bunch of properties that represent our result, and we fire the event. The best source, as I told you before, is actually going to see how the objects you are used to use in your applications are actually implemented. And this probably makes you also a better Titanium developer, because you see how things are really done in the underlying code. Another means of notifying that something happened, but not in general, but tied to a specific operation or action we've done, is using callbacks. So, for example, in this case, always with our XML to JSON module, we don't want to freeze the execution of our JavaScript code on this kind of conversion if we are converting a huge XML document, because it will take a long time. So we decided that we create an asynchronous version of our convert method, but we need to notify the user that we've finished by passing the result through a callback. And how do we implement it? Basically, we have the callback type class, in iOS, and we use this fire event listener method of the proxy object to call the callback with the result object. Don't be too much bothered by this syntax. That's basically is just dispatching this kind of computation to another thread. And the same here, we create another thread for doing the stuff, and when done, in this case we use the callback call method with the same kind of notation. In this case, we more or less always have to pass a dictionary either to event callbacks or this kind of callbacks. Uproxies, finally. Uproxies are a bit more complex than normal proxies. They have to deal with all the UI concepts, and also to the asynchronous nature of the UI creation. So basically we have two kinds of objects. One is the view proxy that holds, basically it exposes the API of our object and also holds the state known to JavaScript of our view object. So for example, the height, the width, the background color, and so on. So this is basically an interface between the JavaScript part and the native part managing the views. And so the view proxy holds this, exposes this kind of API that you already know because you're using it all the time. But the view proxy also manages the native view, or better, a native view hierarchy through a view object. This view object here is, for example, on iOS is a UI view, and on Android is a view object, or better, it's these are objects that inherit from the native views. So the view proxy lives in the JavaScript thread in the same context, while our view objects live in the UI thread and need to be invoked always on the UI thread for allowing us to update the UI. So this kind of communication is mostly asynchronous. So when you, this is kind of fun, because when you basically start using view methods in Titanium, for example, you add a view into another view, you're not actually adding these views, but you're just modifying the proxy hierarchy that will be reflected in a second time on the real view hierarchy, the native one, in a synchronous way. Because maybe you are operating on view proxy objects that are not actually visible because they have not already been added to a window or something like that. So you operate on that kind of stuff, but then in a later moment, all the creation of the UI will happen. So a basic example, actually it's not so basic in the implementation, but let's say we want to improve the performance of our table views. So we are not satisfied with the native Titanium table views. So we want to create a specialized view which is much more performant, and we know how to do it also. And so what we have to do is to create a view proxy object with an associated view object, which basically goes to manage all our view hierarchy. We define a basic API because this kind of object we know that will be managing, for example, a message view with a list of messages. And so we create an application-specific API for this kind of object. And let's don't go in too much detail, but we'll have the possibility to set messages, insert a new message, have some events, and so on. Don't bother too much, but we have the view proxy. We have a model property that holds the collection of messages, which is a wrapper over an array, something like that. And we expose, for example, the insert method, as we saw before, usual stuff. But how do we transfer this kind of information when called by JavaScript to our view to this kind of method that is present in the view proxy class? That is basically make view and perform selector, that is basically and call this kind of method in the view object in an asynchronous way. So this method goes to create the view if it's not already created, and it invokes the method we've defined here in the view object. So on the other side we have the view class, which inherits from TUI view, and which actually is the one that goes to create the UI. So in this case, probably it references a table view controller for managing all the table view stuff. And we have to know that in this kind of class we have the opportunity to be notified by the Titanium framework when something happens that we have to know. So, when the view will be created at some time that we can't know in advance, we'll be notified with a call to this method, which is in initialize state, where we can start building stuff and modifying the UI. Another important method that is called by the Titanium framework and that we have to take much care to implement is the frame size change method that tells us that the frame containing our view has changed in some way. And this will be called several times during the lifetime of our view. So, and it's here that we can set the actual dimensions of our underlying view. And if we don't do this, basically we won't see the actual view, because it will never be, it will never have the correct size, our underlying view. Okay. How can we tweak our module project, for example, for incorporating some third-party library or using some other framework that is not already included in Titanium? And we do this not by adding the frameworks and libraries we're using to our module project, but basically telling Titanium that we are using these libraries or frameworks, so that Titanium, when we'll build the application in a second time, has all the information to link all the stuff together. Because our module on iOS is, once built, will be a static library. And if you use a framework in that library, you can build it correctly, but it won't contain any reference to the framework you're using. You have to tell Titanium that you're using the framework, so that when, in a second time, when we have used the module in our application and we've built the application, Titanium knows what to link to, what to link our application to. And so we do this through the module.xconfig file on iOS, simply telling to Titanium to add these linker flags to the application project on iOS. And so this file will be added to the module package that will be installed and used by Titanium. Titanium, when you build the application, will build the application Xcode project in the build iPhone directory, and we'll add these kind of flags, linker flags, to our project, to the iOS project in build iPhone directory, so that the application can be built knowing this. Otherwise, you will have linker issues, and the application won't be built. Another kind of file that is kind of interesting, mainly on Android, is the tmodule.xml, which is also present in the iOS module project, but I never used it in that context. It's more useful on the Android part, and it's similar to the tieapp.xml file, where you can add information. And in this case, we can add, for example, the permissions that we need, that our application will need for using the features we're implementing in our module. For example, for the previous SMS module, we probably will need the Android permissions and SMS on Android, and maybe we need permission to write to external storage and so on. So we put this information here about our module, or maybe we are creating an Android activity in our module. We also have to declare this kind of stuff here. The build process will simply package also this file in the module package. Will be installed and used by application. When we build the application, both this file, the module file, and maybe the additional sections we added to the tieapp.xml file will be merged and used to create the Android manifest.xml file that will be used for building the final application. Debugging. First of all, on iOS, the first thing I do when I build a module is to take the build script, maybe use it one time for building the first time the package, and then create another script which is the same but with the difference that it basically builds a debug version of our module. Because normally when we build our modules for deploying it, it will be compiled as a release version. So it doesn't have all the debug symbols and so on. So debugging it will be more difficult. So basically, I take this Python script, I replace all the release, all the reference to the release word to debug, as basically are only these two rows, 2 lines, and I create a debug build. I almost finished. So I built the module, I created a test application, I built the test application at least one time with Titanium. I'll open the Xcode project for the application, and I'll import the module project inside the application project. So the big one is the test application project built from Titanium in Xcode. I pick up the module project and I add it to the main application project, so that Xcode knows everything, even about the application and also about the module, so that I can put native breakpoints inside the module code and basically debug as a native iOS application. Otherwise, just using the Titanium application is a bit difficult to debug an object. On Android, we don't have this kind of facilities, so basically we have to rely a bit on the logging facilities, and basically we define a tag for our logging messages, which is the end cap in this case. We also have an additional configuration property that tells us if the application has the debug logging enabled that we can use for our purposes. And so simply we use the log, the command, method in our codes for sending these log messages that we can read using the Android DDNS tool. So I told here log doing something because it's called the do something method, and we find it here in the DDNS tool, which is the debugger tool for Android. And so, thank you.